Alright, so this is our lecture video for section 10.2, which is about finding arc measures. So to start, we're going to start with a little vocab. Our central angle, which we're going to be hearing a lot, is an angle whose vertex is the center of the circle. So, for example, looking at this picture over here, C is the center of our circle. Our central angle, we could use an example as angle ACB. Remember, we use 3 letters to say an angle, so that's just an example for this picture right here. Our central angle is angle ACB. Our next vocab term here is if, minor arc, if the measure of angle ACB is less than 180 degrees. So if it's less than 180 degrees, the points on the circle C that lie in the interior of angle ACB form a minor arc with endpoints AB. Basically, if the measure is less than 180, it's a minor arc. And our notation for that is just we use a little arc like this, and it's going to be 2 letters, AB, just like we see up here. A major arc then is going to be when it's greater than 180 degrees. And the actual definition is the points on circle C that do not lie on the minor arc AB form a major arc with endpoints AB. So basically our minor arc is this small guy here, and then the major arc would be the remaining part of the circle. Again, greater than 180 degrees. So then we had when it's less than 180 degrees, when it's greater than 180 degrees, when it's exactly 180 degrees, we call it a semicircle. So it's going to be exactly half the circle. So if I were to extend this line here, we'd have a semicircle right there, which is 180 degrees, because we know an entire circle would be 360 degrees. And I kind of forgot to mention this, our notation for major arc, we can see it right here. Again, we just use little arc symbol. In this case, we would use 3 letters. Arc A, D, B. And just to kind of re-emphasize that notation, whenever we are naming arcs, a minor arc, so less than 180, is going to be named by the endpoints. And again, we're going to use 2 letters to name that minor arc. The major arc and semicircles are named by their endpoints and a point on the arc, so an included point. So it's going to be 3 letters. And just kind of like when we're doing angles, you just kind of follow the order of the letters. So minor arc AB, it's a minor arc, so we only need 2. Major arc A, D, B, just kind of go in the order of the letters. And that's going to help us when we start measuring arcs. So finding the measure, it's always going to be a degree. When I say find the measure of an arc, your answer is going to be like a degree. And when we're finding the measure of the minor arc, it's the measure of the central angle. So a lot of times this is going to be labeled, or they give us enough information to find it, and we use this italicized M to show that we're finding the measure of arc AB. So that M means measure. And then the measure of the entire circle is 360, as we mentioned before. And to find the measure of the major arc, we just can take the difference between the minor arc and 360. And then again, a semicircle is exactly 180 degrees. And basically it just turns into a lot of addition or subtraction. I think you guys will see that this section is a little bit easier than the last one. So let's take a look at an example. Find the measure of the arcs. So find the measure of the arc in circle P, where RT is the diameter. So looking at RS, well, it's a minor arc, and it's going to be the measure of that angle right there. So it's just 110 degrees. RTS is going to be a major arc because it has 3 letters. So RTS, well, if RT is the diameter, we know that that's a semicircle, so we know this is 180 degrees here. So looking at RTS, it's including all of this. So we could do 360 minus 110 to get that the measure of this major arc is 250 degrees. And then the main measure of major arc, RST, well, that's the other side of the semicircle. So that's just going to be 180 degrees. And the reason I pointed out this 180 degrees here is because, yes, we can just subtract. It's super easy just to subtract to get that 250. Or we could think about it, well, if we know this is 180 degrees, this little piece right here is 110, that would make this piece right here 70 degrees. And we can just use addition to figure out the angles as well, because we can just add them all together. And I keep throwing this idea of addition out there. Well, when we have two adjacent arcs, so remember, adjacent just means they're next to each other, they're connected, they have a common endpoint. We can add them together using arc addition, just like we use segment addition and angle addition, which is just what I showed in the last example. So let's see what that looks like in a word problem. Let me focus this, there we go. So we're taking a survey, and a recent survey asked teenagers if they would rather meet a famous musician, an athlete, actor, inventor, or another person. The results are shown in the circle graph. Find the indicated arc measure. So they gave us all of these measurements already, so this is just going to be a lot of arc addition. So part A here, the measure of arc AC. So looking at this, I go from A to C. It's 2 letters, so I know it's going to be a minor arc. Well, it looks like I'm adding that red and that blue piece together. So I would have 29 plus 108 to get that the measure of arc AC is 137 degrees. I'm just adding them together. Part B here, measure of arc ACD. Well, it's 3 letters, so it's going to be greater than 180. So we have ACD, that goes from red to yellow. So again, I have 29 plus 108 plus 83 to get 220 degrees. So then keep moving forward. Part C here, measure of arc ADC. We have ADC, so it's going the other way. So we're starting from A right here. We got blue, green, yellow. So we're going to have 79 plus 61 plus 83 to get 223 degrees. So hopefully you guys are thinking this is pretty straightforward. So our last one here, EBD, again, follow the letters EBD. So we're starting here from this blue one. We go and add all the way around to the end of the yellow. So we could do 79 plus 29 plus 108 plus 83 to get 299 degrees. And if we think about it, that's almost the entire circle right there. So we know altogether this equals 360. We also could have done 360 minus 61 to get 299. So that's just kind of an example of using arc measures and adding arc measures to find different ones. So why don't you guys go ahead and pause the video and try this example on your own right here. All right, so we're identifying it as a major arc, minor arc, or a semicircle, and find the measure of the arc. Starting with number 1. Well, actually, before I even start this, I see that I have one piece missing right here. So I'm just going to go ahead and figure out what that one piece is. So I'm going to do 360 minus 80 minus 120 minus 60 to get that piece right here is 100 degrees. And that's just going to make my math easier in the end. So now jumping over to number 1, we have TQ. Well, we can see that this is a minor arc. It's 2 letters, and it's less than 180 because we know it's 120 degrees. Number 2 here, it's 3 letters, so it's either a major arc or a semicircle. Looking at our picture, QRT is greater than 180. It's not just half the circle, so this is going to be a major arc. And we're going to have, so QRT, we're going to have 60 plus 100 plus 80 to get that is 240 degrees. Number 3, TQR. Again, it's either a major arc or a semicircle. TQR, well, looks like RT is a diameter plus 120 plus 60 is 180. So this is actually a semicircle, which is exactly 180 degrees. Number 4, QS. Well, it's 2 letters, so it's going to be a minor arc. And looks like QS, we're going to add, oh, I'm sorry, that is not a minor arc, is it? No, it is a minor arc, I'm sorry. Can't think. This way, QRS, 100 plus 60 is 160 degrees. I was looking opposite side of the circle. QRS is a minor arc, it's 2 letters. 100 plus 60 is 160 degrees. Number 5, TS, that is a minor arc. It has 2 letters. And it is just 80 degrees. And last but not least, number 6, RST. We have 100 plus 80. So we know that's going to be a semicircle because it's exactly 180 degrees. And that's just kind of how we go about using that arc addition to figure out the measure of those arcs. And again, we're just looking at angle measures inside the circle. So then a little bit more vocab here. When do we have congruent circles and congruent arcs? So the first vocab here is, when do we have congruent circles? Well, 2 circles have the same radius, then they are congruent. So before we talked about how do we know we have congruent triangles, and we had all these different shortcuts. Well, a congruent circle, we just have to make sure they have the same radius length. A congruent arc has a few different things we have to look at. First, 2 circles have a congruent arc if they have the same measure and the arcs are part of the same circle or congruent circles. So basically, we need to make sure the circles are congruent first, then we can decide if the arcs are congruent, or if it's in the same circle, then we can go ahead and decide if the arcs are congruent as well. So if we take a peek at an example for that, example 3 here, we're just identifying congruent arcs. Let me focus this real quick. Maybe. It's not really focusing, sorry. Okay, tell whether the red arcs are congruent or not. And we really don't need to explain, we can kind of just talk out the explanation here. There we go. Okay, so we're seeing if CD is congruent to EF. We can see they're both 80 degrees because they give us that measurement right there, and they are part of the red circle. So yes, CD is congruent to EF because they are same circle and they're both 80 degrees. I'm okay with a little explanation, something along those lines. Taking a look at part B here. Yes, they're both 90 degrees, but is this circle right here congruent to the larger circle around? No, the radiuses are not the same measure, so these arcs are not congruent because the circles are not congruent. And our last one here, part C, they're both 95 degrees, and this little red tick mark right here tells us the radius is congruent. So the circles are congruent, which means since they both have the same angle measure, the 2 arcs are also congruent. So that's a yes, because our arcs are congruent because the circles are congruent. And they both are 95 degrees. Something along those lines works for an explanation. Not going to be too picky with that, but the big thing here is when you're trying to decide if 2 arcs are congruent, First, check that the circles are congruent, then check that the arc measures are the same. So to wrap up this section right here, why don't you guys go ahead and pause the video and try this example on your own. Say whether they're congruent and tell me why or why not. Again, an explanation like the last example is good with me. Come back when you're ready to check your answers. Okay, tell whether the red arcs are congruent. Number 7, they are congruent because the 2 circles are congruent. And they are both 145 degrees. Number 8, they are not congruent because the circles are not congruent. So even though they have the same measure, they're both 120 degrees, since the radius is 5 here and 4 here, our circles are not congruent, so the arcs are not congruent. So that wraps up section 10.2. Here is your homework assignment, page 651, number 3 through 14. Email me if you have any questions, and thanks for watching.